Welcome to Study Loop.
So in first part of the problem, we have to find the initial pH of the solution. That means the pH of the solution before the addition of acid. So since it is a basic solution initially, 0.115 molar RbOH, that means first we have to know the hydroxide ion concentration here, and from that we will have to find the H plus ion concentration, and eventually we will get the initial pH. So since it's a strong base RbOH, that means the initial concentration of OH minus ion is basically the concentration of the RbOH. So our initial OH minus concentration is 0.115. So from here we can find our initial H plus ion concentration, as we know that there is a relation between H plus and OH minus ion concentration, that is Kw is equal to H plus times OH minus, or H plus is Kw over OH minus concentration, and Kw has a value of 1 times 10 to the power minus 14, while our OH minus concentration here is 0.115. So just solving this, we will have the initial H plus ion concentration as 8.69 times 10 to the power minus 14 molar. So this is our initial H plus ion concentration, and as you know that the pH is basically the negative log of H plus concentration. That means the negative log of this value will give us the pH at that point, or the initial pH, and um, the calculated value is 13.06. So this is the initial pH of the solution. Now let's move to the part B, where we have to find the volume required of the acid to reach the equivalence point. So to find this, we can simply apply the M1V1 is equal to M2V2 formula, where M1V1 are the concentration and volume of base, and M2 is the concentration of acid, and V2 is the volume of the acid required to reach the equivalence point. So from here we can write the volume of acid required to reach the equivalence point will be the concentration of the base, which is 0.115, times the volume of the base, which is 25, over the concentration of the acid, which is 0.1 molar. And from here we can find the volume of the volume of the acid needed to reach the equivalence point, which is 28.8 milliliter. So this is the volume of the acid we need to reach the equivalence point. Now in part C, we have to find the pH at 5 ml of acid added. So to find that, we have to know the number of moles of HCl for 5 ml of HCl. So this is simply the concentration of the acid, 0.1 molar, times so we are trying to find out the number of moles in 5 ml. That means 0.100 mole per liter times 5 milliliter, or 0.005 liter, and this will give us the number of moles of HCl in 5 ml. and it has a value of 0.0005 mole. So this is the number of mole of HCl, and now um, so this much HCl, or this number of moles of HCl, will react with the base RbOH after adding 5 ml HCl. So let's now we set up the reaction. We are adding HCl to RbOH, and in the product we are having RbCl plus H2O. So here we are adding 0.0005 molar HCl to so the initial concentration of the RbOH was, so the initial number of moles of RbOH was 0.002 87 mole. So this we can easily calculate by multiplying the initial concentration of the RbOH with its initial volume, and that will give us the number of moles of RbOH, which is this, and we are adding this much HCl, which is 0.0005 molar 5 mole HCl we are adding. So that means this much HCl will react with the same amount of RbOH. That means it will basically subtract 0.0005 mole acid, 0.0005 mole from the base, and eventually after the addition of uh, 5 after the addition of 5 ml HCl in the solution, we will have the number of moles of base as the subtraction of this, which is 0.0023 or 24 mole. So in the in the solution, after addition of 5 ml HCl, we will have this much base. So now from this, we will have to find the concentration of the base at that point, which will be simply dividing this number of mole by the total volume of the solution at that time. So here we have a 25 ml base solution, so far we have added 5 ml acid. That means we have in total 30 ml in the solution, or 0.0300 liter HCl. So this division will give us the concentration of the acid at that point, which is 0.079 molar. 0.079 molar. So this is the concentration of the RbOH after the addition of 5 ml HCl. And again, since RbOH is a strong base, that means the concentration of RbOH is basically the concentration of OH minus ion. So this is the concentration of OH minus ion after the addition of 5 ml HCl. So from here we can find the value of H plus ion concentration at that point, which is Kw over um, the OH minus ion concentration, which we just calculated as this, which is 0.079, And from here we will find the H plus ion concentration as 1.26 times 10 to the power minus uh, times 10 to the power minus 13. So this is our H plus ion concentration at that point. Therefore the pH will be the negative log of this value, and we will have a pH of um, 12.90. So this is the pH of the solution after the addition of 5 ml acid. Now in part D we have to calculate the pH at the equivalence point. So since it's a strong acid strong base titration, that means at the equivalence point the pH will be exactly halfway between the pH scale, which is 7. And then for the part E we have to find the pH after adding 5 ml of acid beyond the equivalence point. So for this we have to know the number of moles of acid in 5 ml, which you have already calculated in part C. So the number of moles of acid for 5 ml is 0.0005 mole. So this is the number of moles of HCl in 5 ml, since it has a concentration of 0.1 molar. Now so this is the number of moles of HCl added in excess and we have to find its concentration by dividing this value by the total volume of the solution. So to reach equivalence point we have added 28.8 ml HCl, and we had from initial 25 milliliter of base, and now in this part we have added 5 more ml of HCl. That means in total we now have 58.8 molar um, HCl. So the 58.8 molar in total volume. 8 ml total volume. So if we just divide our number of moles of acetic acid, the number of moles of HCl um, at that point by the total volume of 58.8 ml, or we have to divide it by the liter, so we have 0.0588 liter, and this division will give us the concentration of the HCl excess, which is 0.0085 mole per liter or molar. So this is the concentration of HCl excess which we have added after the equivalence point reached. So since HCl is a strong acid, that means the HCl excess concentration is basically the concentration of H plus. So that means just taking the negative log of this value will give us the pH at that point, which is 2.07. So this is the pH after the addition of 5 ml HCl beyond the equivalence point.